Hello and welcome. Today I want to talk about squares. So we're going to learn about properties of squares. Now we all have a concept of what a square is, and we've had that concept for a long time. But we're going to kind of try to look at it in a different way, and that is connecting it to what we already know about other parallelograms, namely rectangles and rhombi. Okay, so before we start to talk about properties of squares, let's just look at a quick reminder here of what a rhombus has. Like the amazing properties of a rhombus is, number one, first of all, in order for it to be a rhombus, it has four congruent sides. All right, so notice that this has four congruent sides. But what happens is when you have all four sides congruent is the diagonals will always be perpendicular, and the diagonals will also always cut the angles of the rhombus in half. So these two are both cut in half, and then these two up here would also be both cut in half. So that's true of a rhombus, and that's something that we should know before we start to talk about squares. And then the other thing is when we look at a rectangle. Now looking at a rectangle, the meaning of a rectangle is that the four angles are congruent. So they're four right angles because they're all the same. And the consequence of that, the properties of that, are that the diagonals become equal. So we already know that in all parallelograms, diagonals bisect each other. There's nothing different for all of them. So this is the same and this is the same, right? And then these are the same. But when you get to a rectangle, those diagonals become equal, because when you straighten out the parallelogram to make a rectangle, then those diagonals become equal. So not only are these the same, and these the same, but they're all the same as each other. All right, so we've already got these amazing properties of rectangles and rhombi. But what you probably didn't know is that every rhombus can be made into a rectangle, and every rectangle can be made into a rhombus. So here, we're looking at a rhombus that's clearly not a rectangle, but if you look at this, all four sides are the same. Oops, I'm going to have to make another one. So when we take a rhombus that's really stretched out like that, and we try to make it into a square, so all four sides are the same, but when I stretch it, not a square but a rectangle, and I try to get all of the angles to be right angles, I'm focusing on the angles being right angles, by the time I get there, it's a square. It's just turned on its side. It looks like a diamond, but just turn your head and it actually looks pretty good just like that. It's a square. So what happens when you make a rhombus into a rectangle is you get a square, right? So that means the square is going to have the properties of the rhombus and the properties of the rectangle. Same is true if you make a rectangle into a rhombus. So here is a rectangle, and now I want to get all, this is clearly not a rhombus because there's short sides and there's long sides. But when I stretch it to try to get all of the sides the same, as soon as that rectangle is a rhombus, it's also a square. So what a square is both rectangle and rhombus. All right, so that means it's going to have all the properties of the rectangle. In other words, the diagonals will be equal and the angles will be right angles. And it's going to have all the properties of the rhombus, which means the diagonals will also be perpendicular and they're going to bisect the angles of the rhombus or of the square. All right, so that's pretty much what we have right here. So this is all that this says, is that when we have a square, we're going to keep all of the properties of parallelograms. We're not going to, because they're always going to be parallelograms. We're going to have the four right angles of a rectangle and the congruent diagonals of a rectangle, but we're also going to have the four congruent sides of a rhombus and the two properties of a rhombus. Okay, so all of the properties are there. So let's take a look at the sides first. Now we're going to, because we have right angles, and now there's two kinds of right angles here. Now let's take a look at a square that has the diagonals drawn into them. And I want you to just kind of tune in for a second on the fact that we've got two different kinds of right triangles. Because it's a square and this is a right angle, we have this right triangle. Okay, and we might use that, and these are going to be optional. You can use sometimes this right triangle or the other one that I'm about to show you. Because it's a rhombus, the diagonals are equal, so these are all right angles. And so this is a right triangle. Okay, so you've got all these different opportunities to use the Pythagorean theorem, and it just depends. Sometimes it depends on personal preference, whatever you see first, or maybe what the question specifically asks. All right, so in this problem, we're looking at AD is 11, so let's name AD as 11. So this is 11, but since it's a rhombus, these are all 11. All right, and I need to find all of the lengths. So what I know here is that I can look at, I think this time I'm going to look at the big right triangle, the first one that I showed you. So I'm going to look at this right triangle because I've already got 2 of the 3 sides of that right triangle. So I'm going to look at that one to get the hypotenuse. Remember that this longer side, AC, is the hypotenuse. So if I temporarily call that x, I'm just going to call that x, then this would be x squared equals 11 squared plus 11 squared. That's x squared equals 121 plus 121. And that's x squared equals 242, which means x is exactly the square root of 242. You want to get a number that means a little bit more to you, you're going to have to put that in a calculator and get a decimal. And the square root of 242 is second square root. I have to push extra buttons in my calculator. It is 15.6, approximately 15.6. All right, so that's the whole diagonal, which means since it's a rectangle, or since it's a parallelogram, diagonals are divided into 2 equal parts. So 16 or 15.6 divided by 2 is 7.8. So that means these are all 7.8. Yeah, this is also. All right, so all 4 pieces of the diagonal, just like a rectangle, they're all 7.8. So let's go ahead and we should have enough information now to label all of our sides in here. So BC is 11. AC is 15.6, right? It's the whole diagonal, so that's 15.6. And if you want to write square root of 242, that's fine too. BD is the other whole diagonal, so that's another 15.6, and it's also 242 in the square root. And then EC is half of the diagonal, so there's your 7.8. All right, that's the first thing you need to be able to do, and you can do that with either one of those right triangles. By the way, had you chosen to do this with, let me just get another color here, let's say with this right triangle, it would have been a slightly different process, but you would have their 11 squared equals x squared plus x squared, and you would have to just solve that equation. How would you do that? Just kind of like make sure that we're clear on that, is you would just take 121 equals 2x squared, divide 121 by 2, and that's 60.5, right? If we divide both sides by 2, we get 60.5 equals x squared, and then take the square root of 60.5. And I'm hoping that the square root of 60.5 will be 7.8, because that's what I got the other method, and the method shouldn't change the values, right? And if you do plug in square root of 60.5, you're going to get 7.77, and we're all rounding here, so it's 7.8. So this means also x is approximately 7.8. All right, so either one of those methods would have worked and been fine. You could look at the bigger triangle or the smaller triangle. It's totally up to you. Okay, now what about the angles? So before we do the angles, I want to remind you of something that we know about another figure that's kind of got something in common with squares, and that's the equilateral triangle. So if we have a triangle that we know is equilateral, and all 3 sides are the same, then we know automatically all 3 angles are the same, right? And since we know that that the angles are all the same, we've got the symmetry here, so we've got a 60, 60, 60. Now, we're not going to deal with diagonals in triangles, not just now anyway, but we can do that with squares. So with squares, we know that all 4 angles are also the same. They're not 60. In the case of squares, they're 90. And that's because all 4-sided polygons have 360, and 360 divided by 4 is 90. Or you could say, no, that's because it's a rectangle, and you'd be right there. There's a lot of reasons that these are 90. But now if we take the diagonals here, I'm just going to draw them in. There's something kind of cool happens here. Now, I don't have to tell you any angles on here, and they're always the same for all squares. Let's think about that, right? We know that this is a rhombus, so these have to be right angles. We know that this is bisected over here, so these are the same. So they each have to be half of 90. Oops, half of 90. So that's 45. So that's pretty much all our angles. We've got 45s all the way around here, all the way around the square. And we've got 90s all the way in the middle. All those intersections in the middle are 90. All right, so it's got that symmetry. So when we're doing the other part, it's actually a little bit easier. So now when we're looking for the angles, they're all either 45 on the outside or 90 on the inside. So that's really the only choices for angles in this square. So when we look at the angles here, and I'm just going to erase this so it's cleaner to look at now, we've got the same situation, right? We've got all either 45, oops, so 45, 45, 45, 45, 45, 45, all 45s, oops, and then I put a 44, and then all of these, when one of them is 90, that means the lines are perpendicular, and of course they're all 90, we don't have to write it in. All right, so given that, we can go ahead and answer these questions about the angles. So measure of angle DAB, you just have to follow it. DAB, that's one of the angles of the square, so that's 90 degrees. Measure of angle AEB, that's in the inside, it's a rhombus. If it's a square, it's also a rhombus, so that's 90 also. All right, measure of angle CBD, that's half, that's right here, so that's 45. And the measure of angle BAC, that's this one right here, that's also 45. All right, so the angles are really quick and they're pretty much always going to be the same. So when we look at example 2, it's just a matter of looking at which angle you're asked for and making sure you get 45 or 90, but you can't really get it wrong if you remember it's one or the other. But I'm going to give you guys a minute and try to see if you can use one. I'm going to suggest that you use the small triangle on this, but you could use either one. Label the TR. So since TR is 17, each one of these is 8.5. Let's just put it in purple here. So this is 8.5. And this is 8.5. And see if you can go ahead and finish solving that, and then we'll compare answers in a minute. Okay, so pause the video, try to work that out, find all the lengths, and we'll go from there. All right, there it is. So I used the smaller triangle this time because I was given that half diagonal, and I have x squared this time as the hypotenuse. So this was my temporary x was down here, and I made that the hypotenuse. Well, it is the hypotenuse. And then I solved that, and I got that all the sides of the square being the same, they're all 12.0. So with that, we can answer all the questions about the square. Now the angles are exactly the same as they were in the other problem. So we can just fill in the answers here and go ahead and fill them in, and then we'll compare. Okay, and there's our sides, the ones that were asked for in this problem, and our angles. We're not going to do 8 and 9 here. This is just review of some stuff with a rhombus, and we've already covered rhombus, so just these two examples with the square. I hope you found this video helpful.